I want to talk about something beautiful. So let's look at this. A car drives. This might take me some time to write, so I'm going to speed up the video. Okay. So a car drives 20 kilometers per hour for 7 hours at a constant speed. Well, let's look at all the ways we can solve this riddle. Let's do it in a grade 1 way. So in grade 1, okay, maybe not grade 1. Let's take grade 4. In grade 4, we might think, well, if the car drives 20 kilometers per hour, that means we can say, well, 20 plus 20 plus 20 is 7 times, plus 20 plus 20 plus 20. What's that? 1, 2, 3, 4, 5, 6, 7. That's going to give me what? 140. So then we can conclude, well, the car drove 140 kilometers. Okay, let's go a bit up. Let's go maybe to a grade 6 level. Now I can say, well, instead of writing 27 times, I can simply say, well, 20 kilometers, and I can multiply this with 7. I'm going to keep it basic for now, okay, without cancellations. And I can conclude, well, 140 kilometers. Now a high school student might think, whoa, that's kilometers and hours, right? But this is a grade 6 student. Let's move over to grade 9. Okay, now we're starting to develop some mathematical thinking. So now we can see, well, I can first drive 20, then I have 40, then I have 60, then I have 80, then I have 100. So we can conclude, well, this is an arithmetic series with a common difference of, or arithmetic, however you want to pronounce it, with a common difference of 20. So now we can all of a sudden use, well, an is equal to a1 plus n minus 1d. And we can solve this using arithmetic. Well, we can say the first term is 20, so we want to find a of 7 is equal to 20 plus 7 minus 1 is 6. 6, the common difference is 20, so that gives me 120. Therefore, a 7 after 7 hours, I would have driven 140 kilometers. Okay. Now all of a sudden, we get a little bit older and we are asked to model something. Okay. So this would be my y-axis. My y-axis is going to be my, let's say it's my speed. Okay. So it's going to be 0, 10, 20, 30, 40, 50, 60, oh man, and 70. Then I have 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. We have our x-axis, which is our time. Now, I'm driving at a constant speed of 20 kilometers per hour, so I can draw a line at 20. Let's give this function a name. So let's say that f of x is equal to 20. Okay. F of x is equal to 20. And I know I'm driving for 7 hours. So I can then say, well, I can multiply this value with this value. So I have 20 multiply 7, which is also 140. And we can just say kilometers again. So let's say, well, the area would then be the length times the width, or the base times the height. We can say that, or we can say base times the height. Since this is a rectangle, we have 20 times 7, which is therefore 140. Now things become a little bit more advanced. Now we learn in physics, well, we can have velocity is equal to distance over time, or speed is equal to distance over time. So we can manipulate this formula to say, well, velocity multiplied time by cross multiplying is equal to the distance. So now we're moving up. Now we're going to grade 10. Maybe I mentioned grade 10 before, but if I did, my apologies. So then we can say, well, I want to calculate the distance. So this gives me the speed, which is the velocity, is 20 kilometers, and I'm driving that over 1 hour. And I want to multiply this with 7 hours. Now we're learning, well, how do these units cancel each other out? So that gives me 140 kilometers. And now all of a sudden, my apologies. Now all of a sudden we get to this. So we know that the function was Vt is equal to 20, right? I'm going to draw the function over here again. That gives me Vt, which was equal to constant speed of 20. And I want to find the time or the distance that I've traveled from 0 to 7. Now we're getting to a grade 11 level. Maybe grade 12. I think maybe grade 11 more. Now we can say, well, Vt is equal to 20. So what if I integrate this function? Dx. And I want to define it at the highest value of the function of 7, and the upper function and the lower function of 0 and 7. So to solve this, I can say, well, I'm going to use a little technique where we have x n plus 1 over n plus 1. So what does this mean? This means currently I'm given this situation, but with more practice you will start understanding these fundamentals. Currently I have x to the power of 0. So let's define this equation quick. So that's going to be 0 times 1, which is, or 20 times 1, which is simply 20. So now I can say, well, if I have to plus 1, I can say, well, 20 times x 0 plus 1 over 0 plus 1, which is simply just x to the power of 1. So now I have 20x. That becomes all of a sudden 20x. And we're going to add our constant of c. Why do we do that? Again, because the derivative of any constant is 0. So the antiderivative of 0 will be c. And I'm going to evaluate this at the function 7 and 0. So what do I do now? Well, now I'm going to use this thing again. I've spoken about this in previous videos, where we have the function of the upper limit, the upper function, excuse me, minus the lower function. So I can now say, well, 20 multiply 7, and I can subtract this from 20 multiply 0. And all of a sudden, after using integration, I get 140 kilometers again. So now we've seen how we can go from easy arithmetic to easy addition to multiplication to arithmetic to area and then to integration to solve the exact same question multiple different ways. And what's funny enough is there's more. There's more ways you can do this. And that's what makes mathematics so beautiful, that we can verify every single equation through proofs. Right? Look at that. Beautiful.